Hi, today we're going to go over the build of a Eggtimer Proton. The Proton is Eggtimer's real powerhouse flight computer. It doesn't have GPS like the Quasar, but it has a lot of other features that the Quasar doesn't have. For instance, it has both a barometer and accelerometer, a lot of ways to do air starts with 6 channels of deployment, Wi-Fi capability to program the computer itself. You can download the flight data afterwards and use it in many ways in a CSV file. It really is pretty much the most powerful flight computer Eggtimer sells when it comes to complex flights like air starts and staging. It also has a couple different methods of doing tilt detection during flight using either an accelerometer and barometer measurement or a velocity and altitude measurement to make sure that if you do air starts or staging, your rocket is pointed vertically. This is my setup for soldering. I use a Hakko FX7 972, excuse me, with a 0.3 millimeter tip on my soldering iron for most of the components. You don't need anything this complex, but this is a pretty complex build. There's a lot of parts, a lot of different kinds of parts, so you probably need something more than just a cheap stick solderer. I do use my own Kester soldering wire, and make sure you use a vent fan or some kind of device to get those fumes away so you can be safe. So we're going to open up the package here as it comes from Eggtimer, take out all of our parts, and we're going to do the standard inventory that we do in the beginning of all of my videos. You can skip over this if you want to just right to the build, but I do recommend that you do the inventory and actually check each part off. Mainly because, obviously you want to know if you've got all the parts, but especially in a build like a Proton where there's a lot of parts, you want to be able to identify them very easily. And by doing the inventory, you become familiar with the parts before you go try and put them onto the board itself. So get them all out on your mat or surface or whatever you're going to use. And then I like to take this Wi-Fi passkey and cut it out and put it to the side, and I keep it in the same package as the flight computers after I'm done. And I also write that number onto the chip itself. You'll see that at the end, but don't lose this. You can get it later on by connecting it to a computer, but it's a lot easier if you have this put to the side. So here's all our parts. Like I said, we're doing the Rev C14. This is the latest version as of October 24 when I'm doing this. This is the main PCB that you're going to be soldering everything to. So take that, check it off on your list. And then the next component is the Wi-Fi module. Same Wi-Fi module you see on all of the other builds with Eggtimer. We'll go through that. Next up, you've got an EEPROM. It's a 8-pin package right here, and this is what it looks like. Pretty distinctive for this build, although it looks very similar to the drivers, so make sure you disambiguate that. Next up, you've got the port expander. Really hard to miss this one. This one's 24 pins. It's the only 24-pin chip in the package, and it's very distinctive. Then you have the driver packages, and there's 6 of these. They look very similar to the EEPROM, but you can tell this one because there's a whole bunch of them in the package. You've got a MOSFET here, and it's a 3-pin package, pretty standard on a lot of these builds as well. All right, put that to the side. Next up, you've got a rectifier. Once again, pretty simple to tell. It's kind of a two pins on one side with a short pin and one large pin. Next up, after the rectifier, you've got your voltage regulator. This is a 3.3 voltage regulator. Again, very similar to the ones you might have seen in other Eggtimer builds. Next up, is another FET, but this is a small FET. You get 2 of these. You're only going to need one of them. They're very small, so I think that's why they included 2 of them in case you lose one. But that's what the FET looks like. All right, next up, you're going to get an Optoisolator. It's a 4-pin package, rectangular in shape. There's one of these. Okay. After the Optoisolator, pretty standard buzzer. You see these on a lot of Eggtimer builds. It is polarized. There is a positive and negative terminal. We will make sure that we identify that when we get to that part of the build. Now we're going to do all the resistors. There's a lot of resistors. So we're going to start off with some 4.7Ks, some 1Ks, and some 330 ohm. You got you're going to get one extra on each one of these resistors. So that's what those look like. And then there's one more set of resistors. You've got some 10Ks, some 22Ks, and some 100K resistors. And once again, you're going to get one extra on each one of these in case you lose one. They're easy to lose. They're small, and if they fall on the floor, they're hard to find. So that's what those look like. Next up are your capacitors. Now this one, you have to really make sure you know what you're doing here. This is the 0.1 UF capacitors in the white paper carrier. There's 4 of these as opposed to the 10 UF ones, which we're going to show you next. The 10 UF ones come in a plastic carrier that looks like this, a clear plastic carrier. The problem is when you take them out, they look very, very similar, almost exactly the same. The 10 UF ones are a little bit bigger, but it's hard to tell. So don't mix these up, and really make sure when we get to these portions of the build, you know exactly which one you're using and put them in the right place. You've got a bunch of wired resistors here. You don't need the resistors themselves. These are going to be to wire up the Wi-Fi module. And then you've got a 2-pin jumper with a shorting jumper. A 2-pin header, apologies, with a shorting jumper. And then you've got a 4-pin angled header right here. You can see that the long pins are angled on this one. All right, next up, you've got 2 terminal blocks. Pretty distinctive, although we'll show it on the build, but make sure you remember which side goes out. That's the one with the holes, not the side that's blocked off. And then finally, you've got some soldering wire from Eggtimer. This is really good stuff. I will be using my own. I have the same stuff on a spool, but if you don't have that high quality soldering wire, please use the stuff from Eggtimer. All right, so we've inventoried all our parts, and we'll get on with the build. As a reminder, we are going to be doing the Rev C14 version. Okay, the first component up are these very small FETs. You're only going to need one of these, and they go right there in the center of the board on those 3 pads. So all you need to do is I tin the single pad first, and then heat up your solder and move your component into place. It's small. It's very hard to get it exactly on those pads, but and the pads are much bigger than the pins. But once you have them centered on there, just solder on those 2 pins, and then resolder that single pin so that you make sure you got a nice bit of solder. It doesn't need to don't bridge any pads or go onto the chip itself, but just cover the pins with a nice tent of solder. Next up is the Optoisolator, and that goes in that square part at the top of the board there. Now remember, there's a small dot that I'm pointing at there with tweezers, and that lines up with that square. That's pin 1. You have to make sure it's oriented correctly or it won't work. So tin one of the pads, move it into place, ensuring that the dot is lined up with the white square, the white solid square at the bottom of the diagram there. And then once you have it in place, just like the FET, you're going to go ahead and solder each pin on. Now when you do these pins, you want to get a little bit of solder underneath, and you want to make sure that that tent is nice and shiny and that it covers the pin completely, but doesn't go all the way up to the chip or bridge to one of the other pads. Once you get down, we're going to move on to this port expander. 24 pins. This one's a little bit tough to get lined up properly, but you see, again, there's a dot and you need to line that up with the solid white square. That's pin 1. Again, make sure it is oriented properly or the chip will not work and the board will fail. So just like the other one, tin one of the pads and move your whole package into place. This one's a little tough to get lined up, but you got to get all those pins lined up on all 24 pads, square and then even between side to side. There you go. Once you got the chip in place, you can see it moving there a little bit. Once I get that opposite pin soldered, I just held it down in place, and now it's nicely not going to move. So then just go around, and all you have to do is solder each one of those pins. We're gonna speed this up a little bit because they're all the same. But basically, you just go around the entire chip, solder each one, make sure enough solder gets up underneath each pin with a nice shiny tent so you don't have a cold solder. Sorry about the blurry on that one. You should be able to see this one a little easier. But this is the sped up version. But just go ahead and solder each pin in place. Now we're going to do these driver chips, 3 at a time. We'll do one here, but these are a little tougher to figure out. They have a bevel on one side, and that lines up with that pin 1, that white square. Also, the lettering faces the outer edge of the board. That's another way you can tell whether it's lined up properly. But it really, all 6 of these need to be put in properly with the right polarity. So that pin 1 needs to go into the right place. So make sure, so tin a pad, put it in, tack it in place, and then go ahead and solder all the other pins just like we've done with the other chips. So we're going to move this along and start speeding the video up here. But these are all the same now. So once we get past this chip, we'll solder this one in real time. Now that you do notice that those 2 middle pins are a single pad. Make sure you cover them nicely and get both pins in there. But from here on out, it's exactly the same. You're just going to get those next 2 chips in place, bevel to the outside towards that dot, and you're just going to tin the pads. Move the chips in place to tack them in, and then solder each pin just like we did the first chip. As you move through this build, these are probably some of the toughest ones to make sure you've got it right. It's kind of easy to see in this video because it's zoomed in, but I can tell you that when you're trying to do this with the naked eye, it's tough to tell where that bevel is. So I'd recommend using a pair of some sort of magnifying loop or something to help you figure out where the bevel is and what the orientation of these drivers are, so that you don't put them in backwards. At the end of the day, the easiest thing might be just to notice that the writing is facing the outside of the board. So here are the other 3 on the opposite side. We're going to, again, speed this up. And you're just going to, exactly the same way, notice that the bevel's opposite now. It's going to the outside of the board, just like the writing is. So the orientation is similar to the other ones. It's just mirrored. So get those all soldered up, and then we will move on with the build. All right, next up are we're going to start the resistors now. First up are these 10K resistors. There are 5 of them right now that we're going to put in. Pointing them out on the board. They're marked 103. Okay, for these surface mounted chips, the way you put them in is you tin 1 pad, take your chip with your tweezers, slide it into that, heat up your tinned pad, slide it into place, get it even both left and right, and kind of centered on the pads, and then you're going to solder each end. First, let's get the rest of them in, and we'll do these in real time on this portion. But and notice there, if it moves or it's not in the right place, go ahead and just reheat it, move it till you get it till you're happy with where it is. But we'll do all of these in real time. But then as we start to move to the other resistors, we will speed up the video. So because they're all the same technique. and you don't want to just sit here forever watching resistors being put in surface mounted parts. So go ahead and solder the other side of the chip. You want enough solder there to get underneath the chip on the pad to give a good contact, and a little bit of solder to go over the top of the end of the chip. But you don't want to bridge the chip underneath. You don't want to go completely over the chip with the solder. Just enough to secure the chip into place and to make sure you have a good connection. So same thing, we'll do this last 10K in real time so you can see it. And then we'll move on. Next up, you got some 330 ohm right there by the first 10K chip, and we'll start speeding up the video now. Okay, now the capacitors. The first one's up, the 0.1 UF white paper carrier. Don't mess these up. They are very similar to the 10 UF. They look very, almost exactly the same. The first one we're going to put in, marked C104, right there by the FET we put in earlier. And you're going to use the same technique that you used for the resistors. You're going to tin one pad, slide the chip into place, and then make sure it's centered. And then once it's tacked in, solder the ends of the capacitor in the same exact way as the resistors, enough to get underneath on the pad for a good contact, and enough as just a slight tent and bubble. All right, the voltage regulator, this has a large pin on one side. So tin that large pin, get some solder on there, heat that up, and then slide it into place so that all 4 pins are centered on their pads. That's one of the first key things. Now the second thing is, for this particular chip, you have to wait at least 30 seconds between soldering in the pins so that you don't overheat the chip. So I'm going to cut that part out of the video so you don't have to sit there and wait for 30 seconds, and I'm going to actually speed up the video. But I did wait 30 seconds, and you must too, to not ruin your voltage regulator. So after you've done waiting your 30 seconds in between each and soldering each pin, just like all of the other pins we've put in, go back and resolder that large pin at the end with a good chunk of solder. That acts as a heat sink. Okay, now here's the 10 UF. These look identical to the 0.1 UF, but they're in the plastic carrier, and they're going to go into the 2 spaces right around the voltage regulator. But we'll speed the video up here because they go in exactly the same as the 0.1 UF ones. You just tin a pad, tack them in place, and then solder each side. And from now on, all of these surface mounted parts, we will speed the video up, including these 4.7Ks. There's one right there that we need to put in, and same technique. Okay, now we've got a 1K resistor that needs to go in right next to that. Get that one put in place. And then a 22K that goes in right next to the 1K. All right, next up, we've got a whole line of these 10K resistors that need to be put in place. There's 5 of them between the drivers, and then there's a 6th one right at the end of the drivers. Nothing special here. It's just that there's a lot of them. So just tack them all in place and then solder them in. Kind of an easier one. Now that you should be getting used to these surface mounted chips, they're pretty simple once you get used to them. All right, with the 10Ks in place, the next thing up is this large rectifier. Now this one has a really large pad on one side, but very similar to the voltage regulator. Just tin that pad, get some solder on there, and then heat that solder up and slide the rectifier into place so that the 2 small pins are lined up and centered on those small pads, and the large pad is kind of centered in the big pad on one end. Let that cool off for a second, and then very standard here, we've done this a number of times now, solder those 2 small pins in place. And then just like the voltage regulator, go back and solder the large pin and make sure you get a good chunk of solder on top of the tab as well. Okay, rectifier's in place. Next up, you've got another one of these 4.7Ks right at the end of the drivers, get that in place. Okay, other side of the board. So flip your board over and we're going to get the EEPROM in. You can see that the same thing here. You've got a dot and then a square. In this case, it's not a solid square. It's a square outline around one of the pads. Those two need to line up, the pin and that white rectangle around one of the pads. That is pin 1. Make sure they line up. But just like all of the other chips that are very similar to this, tin 1 pad, make sure all 8 pins are lined up on the pads. Once you're comfortable with that, solder each pin in. Okay, EEPROM is in place. Next up, you've got some more 0.1 UF. These are the ones in the white paper carrier capacitors. We'll speed up the video here, get them tacked in and soldered in just like all of the other surface mounted chips. All right, now we've got some more 4.7K resistors. There are a lot of resistors and capacitors on this board. You get a lot of practice putting these surface mounted parts in if you haven't done it before. So get these soldered in, and then we're going to move on to the Wi-Fi. For the Wi-Fi module, I like to use the silicon mat. You're going to take the module and the through-hole resistors that come with the kit, and functionally you're going to put the resistor wires in the holes and solder them in as pins. So just lay it out, and then what I like to do is then tape the module right to the silicon mat that I use. And this is a silicon mat that's specifically designed for soldering. I'll put a link down in the description here. And the nice thing about using this mat is you can just put the wire right into the mat. It's kind of self-healing when you pull it back out, but it sticks there nicely and it holds it in place vertically while you're trying to solder it. So I stick the first pin in through the hole and into the mat, and then I do the opposite corner with another resistor wire and solder that one in. Now functionally your Wi-Fi module is stuck to the mat. It's not going to go anywhere. You could take the tape off if you wanted to. And then just use your clippers to trim the wires about halfway down from the resistor itself, because you're going to need to do this all the way around all of the holes. So from here on out, I'll do one more in kind of real time, but just go to each successive hole, push the wire through the hole into the mat, solder it in place, and then trim it. And then we'll speed up the video here because it's pretty much the same all the way around now. But each time you do this, you want to cut the wire off about halfway, give or take, up to the resistor itself. It's really, you've got plenty of wire here. At the end, when you go to actually put this on the board, you'll find that the long wires themselves, you've got plenty to deal with. So it's not imperative that you get it exactly halfway or the same. We'll even everything out and straighten out the wires afterwards. But for now, just go around and put each wire in each hole, solder them in. You don't need a lot of solder either. At this point, you're just basically tacking in the wire. Later on, we will solder up the top of the Wi-Fi module a little bit more to make sure you have a good connection. Right now, you're just trying to get the wire to stay in place vertically. And so as you get to the end here, you're going to get to the last couple wires in. Then you're going to take the tape off and pry the module out from the mat itself. And then I find that the easiest way to straighten everything out is to take just your flat tweezers and kind of align everything perpendicular to the module itself. So kind of do it lengthwise along the module, and then go back and look at each individual pin, and you'll see that it looks pretty ugly at the beginning, but within a minute or so you can align everything properly and have fairly straight pins. And then once you get them all aligned, relatively speaking, we'll make sure we'll kind of get them in place when we go to put them onto the board itself. But then take your clippers and then just even everything out. You don't have to, once again, it doesn't have to be perfect at this point. The main intent is to just make it easier to get it into the mounting holes on the board. Do be careful when you do this. I like to put my finger over the ends of the wires because it does have a tendency to spit out little chunks of wire there that can get all over the place or get in your eyes. So just be careful when you're trimming off the ends of these wires, and control the pieces that are flying off. And that's so that at this portion, that's it. Just once again, take a look at the wires. Make sure they're straight. Don't worry about the top right now because that's pretty irrelevant at this point. We'll trim all of those off later on. Okay, now that you've got everything installed onto the Wi-Fi module, you just need to line up all of those pins onto the board. You can see that the Wi-Fi module itself goes at the end of the board, and the flat piece goes to the outer edge, which should make sense. It fits in that white square. It's easiest, I find, just to get the pins close and then use your tweezers to just make those minute adjustments. Now, I then tape the board down, but you can see underneath the tape, I probably didn't show it on the video, there's a white piece of cardstock. That cardstock just allows to have a little bit of space between the board, the Wi-Fi module, and the PCB. You don't want it resting right down on the board. So once you get that taped in and you've got some kind of spacer in there, just turn it over and solder each pin. You'll see they move around, they're kind of wobbly. It's because you're heating up the solder on the chip itself, but just keep them as centered as you possibly can and solder them all in securely with a nice little tent. Pull that cardstock out if that's what you used, and then go ahead and solder the tops of the connecting wires as well. I've seen that a lot of times. This is usually, you can see that some of them don't have any solder on them at all. This tends to be the spot where the most errors come in with these Wi-Fi modules on the Eggtimer boards, that the tops haven't been soldered properly and you don't have a very good connection. So just go around, solder those in, and then clip everything off. Now, as we're clipping off these wires, these excess wires on both sides, control the piece you're cutting off. They have a tendency to go flinging off with your wire when you cut them with your wire cutters, and they could get in your eye. They get on the board. You can see here that some pieces are getting on the board. When you're done, make sure you go back and take all those pieces off. Just a quick pro tip here: you can use a piece of tape to get them all off your work surface too. All right, the buzzer is polarized. Notice you have a plus on one side, and that goes to the plus on the board. And also, the other indicator is the positive pin is longer. So make sure that longer pin goes onto the positive side hole in the board, and it just drops in place. Tape it down, turn it over, and solder those pins. You'll have to clip at least the long pin, and just make sure that when you clip them, just like our other pins, you control that and don't let them go flying, as they are a hazard. But go ahead and trim those down to the board, and should be good to go. Okay, now we have to cut this angle header into a 1 and a 3. I find the easiest way is just take your wire cutters, put it right in that notch there, and just clip them, and they come apart really easily. So take the 3-pin header and put the short pins, obviously the bent pins go on top, and they should go over the Wi-Fi module, and just drop it in just like that. Now, when I tape these down, I just put the pins right through the tape. Makes it easy, keeps it flat. If you try to tape it down, otherwise it's hard. Solder those in, and then take that single one that we just took out. Assuming you're going to use a telemetry board, I almost always use a telemetry board with my Protons, so I always want these in. But same thing, I angle it a little bit out over the Wi-Fi module. It makes it easier later on when you go to try to connect the connector to it if it's not tied up right next to that buzzer. Then the 2-pin header in the program spot, same thing, put it in, tape it down, and solder it on the other side. Easy. Now, these terminal blocks, make sure that opening is pointing out away from the center, or else you won't be able to connect wires in there. So make sure that on both sides that it's pointing out to the edge of the openings are pointing to the out of the edge of the board, not to the center. Once you have them in place, just tape it down and turn the board over and solder all 12 pins securely. Speed that up. All right, here we go. Now that we've got the terminal blocks in, we're getting very close to the end. Next up is this MOSFET. It's a 3-pin chip, and you got to make sure that that solid metal backing goes towards that solid white, large solid white line. In other words, towards the end of the board. But you can just push that in. Mine was pretty tight, so I didn't need to tape it. But if yours isn't, then you should tape it up. But get some solder on each one of them, and get enough around the pad, a nice little tent to make sure that the MOSFET stays in place and it has a good connection. Then again, good wire management here. Make sure you control those cutoffs as you trim the wires. Okay, with the MOSFET in place, we need to put a battery connector in. I'm going to use a 2S LiPo to power this for now, so I'm going to put a JST connector on. Make sure you got the polarity on that right as well. The red wire in this case goes to the positive and the black to the negative. So turn the board over, put the wire through. I like to use a pair of helping hands here to hold the wire in place and then solder it. Now, if you're going to use a dual battery configuration, we're going to configure this for a single battery configuration. In other words, one battery will power the computer and the deployment charges. Many times I use a separate battery for the deployment charges. If you're going to do that, you would have to wire this up a little bit differently and determine which kind of batteries you're going to use. Often when I want to do clusters and air starts, though, you want a different battery. But for now, since we're going to do a single battery, we need a jumper in the spot where you would put the dual battery, where it says DP plus and B plus. So you need to jumper that for now, at least for testing purposes. If you don't know which one you're going to do, go ahead and jumper that for now. Just use a little bit of solder so that you can remove it later if you have to. But for testing purposes, we're going to solder that jumper in place. But that's it. That's the board. It's complete. So we're going to move into testing. And in order to test it, all you need to do is to connect a battery to it and then check it for Wi-Fi. So here's the battery I'm going to use, and you should hear some beeps when you first connect the battery. Okay, that worked. That's what we should be hearing. Now we need to connect it to the Wi-Fi, and this is the screen you should get in your browser if you've done everything correct. You can go to the settings page. You should see all of the channels, and you should be able to arm it from here. So that's it. That's the entire build. We're going to write. I like to write, as I noted earlier, the Wi-Fi passcode right onto the Wi-Fi module. That way, if I ever lose that little white piece of paper, or I'm at a launch and I can't remember what the passcode is, and I don't have the phone I had originally used earlier, or whatever, it's not registered in my phone's Wi-Fi. This makes sure you never lose that passcode. Just put it right on the chip, or right on the Wi-Fi module, and you should have it forever. All right, so that is the entire build. It's not an easy build in the sense of there are a lot of parts. There are a lot of surface mounted parts, but I think if you're not too used to doing surface mounted parts, once you finish this build, you should be pretty comfortable with them. I personally think they make it a lot easier in through-hole pieces. The Wi-Fi module is one of those slightly complex parts, but hopefully, if you have any questions or if you're confused about anything, put it down in the comments, and I'll try to answer it. But this build went well. Hope yours does too. Have a great day. Thanks.